Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on volume and volume relationships. The last time we were together, we went over 4 types of chemical reactions: combination reactions, decomposition reactions, single displacement reactions, and double displacement reactions. We also learned that a composition reaction is a reaction in which 2 or more substances combine to form a single substance. We learned that a decomposition reaction is a reaction that involves the breaking down of a single compound into 2 or more elements or simpler compounds. We learned that a single displacement reaction is a reaction in which one element displaces another element from its compound. We also learned that a double displacement reaction is a reaction in which 2 compounds react together to form 2 new compounds by exchange of the positive and negative ions of each reactant. So far in our lesson, we primarily focused on the double displacement reaction. We looked at several different examples of this sort of reaction and learned how to distinguish it from the other types of reactions. In the meantime, you have been learning about molar ratios in balanced equations and mass-mass relationships. In today's lesson, we are going to learn about volume and volume relationships. We will define molar volume and state Avogadro's principle. We will also solve volume-volume problems based on a given chemical equation. Let us get started. Volume itself refers to the amount of 3-dimensional space a substance or shape occupies or fills. In reactions that involve gases, the volume of the gases can be determined based on the principle that 1 mole of any gas has a volume of 22.4 liters at STP. A mole is a unit of measurement in chemistry, and STP is short form for standard temperature and pressure. At standard temperature and pressure, the temperature is at 0 degrees Celsius, and the pressure is at 1 atm. Atm represents the standard atmosphere, which is at a pressure of 101,325 pascals, or 760 millimeters of mercury pressure. It is known that 22.4 liters of any gas weighs exactly its molecular mass when standard temperature and pressure are present. Thus, molar volume is when a gas is at a volume of 22.4 liters. To clarify, at standard temperature and pressure, 1 mole of any gas is equal to 22.4 liters, which is equal to the gram molecular mass of the gas. Students, let us do an activity. In a moment, you will see a table. Match each term in the left column with the definition that best describes it from the right column.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You were correct to say that a mole is a unit of measurement equal to 22.4 liters. Volume is the amount of three-dimensional space a substance or shape occupies or fills. If you said that STP is standard temperature and pressure, you are also correct. Let us move on with our lesson. Italian scientist Amedeo Avogadro was the first to propose that the volume of a gas is in proportion to the number of moles or molecules. The nature of the gas has no effect on this. The same volumes of different gases under the same temperature and pressure conditions contain an equal number of molecules. Thus, the volume of a gas is proportional to the number of molecules, or moles, of the gas at standard temperature and pressure. In volume-volume problems, we are given the volume of one substance and asked to calculate the volume of the other substance. Let us go through an example so we can fully understand how to answer these volume-volume problems. We are given one substance, which is 20 liters of carbon dioxide at standard temperature and pressure. What volume of oxygen will react with carbon monoxide to produce this amount of carbon dioxide? Well, first, we need to write a balanced chemical equation, which would look like this. The next step is to place the given volume and the required volume, X, above the corresponding formulas. We would place the X above the oxygen symbol and the 20 liters above the carbon dioxide symbol. Then we write the total molar volume, which is 22.4 liters, multiplied by any coefficient below the formulas. This step is followed by setting up the proportion. Then we solve for the unknown volume X. In this case, 10 liters of oxygen are needed to react with carbon monoxide to produce 20 liters of carbon dioxide. Students, let us do an activity so we can practice what we just learned. What volume of nitrogen reacts with 33.6 liters of oxygen to produce nitrogen dioxide?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you said 16.8 liters of nitrogen reacts with 33.6 liters of oxygen to produce nitrogen dioxide, then you are correct. In today's lesson, we learned all about volume and volume relationships. We defined molar volume. This is when a gas has a volume of 22.4 liters at STP. We discussed Avogadro's principle. This video is a review of that principle. We also learned how to solve volume-volume problems by looking at an example and then doing one for an activity. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.